రైట్. స్క్రీన్ కనపడుతుందమ్మా క్లియర్గా? హలో, ఆర్ యూ ఏబుల్ టు సీ స్క్రీన్? ఓకే అమ్మా, థ్యాంక్ యూ. రైట్. See, in the last class, we have discussed some preparation methods of alcohols, right? Now, let us discuss continuation of preparation methods. Actually, I told you that we will discuss questions related to alkyl halides and aryl halides, right? That let us discuss on Monday because how many of you have prepared the concepts? Right? If all of you ready, then I'll start discussion of questions, or else I want to continue with the preparation methods of alcohols. Tomorrow you can prepare. On Monday, definitely I'll discuss the questions. Right? Now, see, preparation of alcohols. See, preparation of alcohols from aldehydes and ketones. Right? From aldehydes and ketones. See how it is possible to convert aldehydes into alcohols, similarly ketones into alcohols. C. R C double bond OH aldehyde, R COH. One hydrogen is added to the oxygen and one hydrogen is added to the C double bond O carbon. Right? So addition of hydrogen, it is reduction. So aldehydes can be converted into alcohols by reduction. Right? Similarly, in case of ketones, also we have to add one hydrogen to ketonic oxygen and another hydrogen to C double bond O carbon. So by reduction, aldehydes and ketones can be converted into corresponding alcohols, right? By reduction. Now, see what are the suitable reagents to convert or to reduce aldehydes and ketones into alcohols, right? So, first method is hydrogenation in presence of metal, right? What are the metals used in this process? That may be palladium or platinum or nickel, right? Now, second method is by reduction with lithium aluminum hydride followed by hydrolysis. Lithium aluminum hydride followed by hydrolysis. Uh, కేజీబీవి మహబూబాబాద్ నోట్ చేసుకోలేదు అని మెసేజ్ చేశారు నాన్న. నేను దీన్ని పీడిఎఫ్ పెడుతున్నాను గ్రూప్లో, రైట్? సో నోట్ చేసుకోవద్దు, జాగ్రత్తగా వినండి. ఈ పీడిఎఫ్ను పెడతానమ్మా. రైట్. అలాగే మీకు ఈ వీడియోని రికార్డ్ చేసి యూట్యూబ్లో అప్లోడ్ చేస్తున్నారు. సో ఏదైనా డౌట్ ఉంటే యూట్యూబ్లో వినొచ్చు, లేదా ఈ పీడిఎఫ్ను చెక్ చేయండి. ఇంకా డౌట్ ఉంటే అప్పుడు నేను ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే. నౌ థర్డ్ రియేజెంట్. See, third reagent is sodium borohydride. Sodium borohydride followed by hydrolysis. H2O or ethyl alcohol. Right? 1 second. Now, fourth reagent. See, fourth reagent it is sodium in presence of alcohol. Sodium in presence of alcohol. Now, fifth reagent it is B2H6 hydroboration in presence of THF, tetrahydrofuran, THF. See, this is furan, right? Now, each hydrogen it consumes two hydrogen atoms. Sorry, each double bond consumes two hydrogen atoms. So here one hydrogen, and over this carbon one hydrogen. Similarly, here one hydrogen and here one hydrogen. So each double bond it consumes two hydrogen atoms. So after consuming the hydrogen atoms, there will not be double bonds, right? So four hydrogen atoms are consumed by two double bonds. So it is called a tetrahydrofuran. It acts as a solvent. Tetrahydrofuran. It acts as solvent, right? So these are methods. Now let us see mechanism for the reduction using lithium aluminum hydride, right? Lithium aluminum hydride or sodium borohydride, NaBH4. See, let us take alcohol. I'm sorry, let us take aldehyde or C double bond OH. Now, aluminum hydride, AlH4 minus, right? AlH4 minus. See, in C double bond O carbon, due to more electronegativity of oxygen, oxygen gets partial negative charge and carbon gets partial positive charge. So due to partial positive charge, here hydrogen with its electron density, it undergoes nucleophilic addition. This is nucleophilic addition reaction. Nucleophilic addition reaction, right? So hydrogen with its electron density, it undergoes addition with this carbon. Now this electron density, the pi bond between carbon and oxygen goes to the oxygen. RCO. Now here H and H. Now this O minus, it reacts with AlH3 minus. AlH3 minus, right? So like this, in AlH4 totally there are 4 hydrogens. One hydrogen with its electron density as H minus added to the carbonyl carbon. So this is nucleophilic addition. Nucleophilic addition. Similarly, remaining 3 hydrogens also they undergo addition with carbonyl carbon of aldehyde or ketone. So let us take more 3 moles of aldehyde or CHO. Right? Now it gives C here or CH2O taken 4 times, right? Al minus. Al minus. Now this is subjected to the hydrolysis. 4 moles of water. See water it is H plus and OH minus. So H plus will be added to this O RCH2OH. It converts into RCH2OH and 4 moles of OH minus. They bond with aluminium to form AlOH taken 4 times minus. Right? Now, this is the mechanism. So like this, aldehydes and ketones can be converted into alcohols by using lithium aluminum hydride. The same mechanism we can apply for sodium borohydride. Here we will get BH4 minus. So in the place of aluminium, if we take boron, the same mechanism we can apply with NaBH4, right? Now, what is the difference with the lithium aluminum hydride and sodium borohydride? See, lithium aluminum hydride is highly reactive or very reactive. So, if water is added in the first step itself, it reacts with the water. Instead of nucleophilic addition, lithium aluminum hydride reacts with the water to form lithium hydroxide and other products. So, H2O is added in the second step, right? So, lithium aluminum hydride readily reacts with the water. So, water is added in second step. Water is added in second step. Whereas sodium borohydride, it does not react with the water. So, we can add water at the beginning of the reaction, right? I'll write here. Lithium aluminum hydride reacts readily with water. So it is added in second step. NaBH4 does not react with water, right? So this is the mechanism. So 1 mole of aluminum hydride, lithium aluminum hydride can reduce how many moles of aldehydes into alcohols? 4 moles of aldehydes into alcohols, right? Now, see here. Second. Right. Now, for example, RCOH. Aldehyde, it is allowed to react with lithium aluminum deuteride, LiAlD4, LiAlD4, right? And the second one is water. Instead of hydrogen, deuterium is taken. So, what is the possible product? For example, in the option A, it is given like this: R, C, O, D, H, H. Option B is R, C, O, D, D, H. Option C is R, C, O, H, D, H. Option D is all are possible. Right now, these are the four given options. The what is the correct answer? Based on earlier mechanism. See, observe the mechanism carefully, then you can answer easily. By observing this mechanism, you can answer to the question easily. Observe this mechanism carefully. What I'm trying to tell you is the hydrogen bonded to the carbonyl carbon is coming from which reagent? And hydrogen bonding to the carbonyl oxygen is coming from which compound? If you observe that carefully, you can find out the answer easily. Right. See here, hydrogen bonding to the carbonyl carbon. Hydrogen bonding to the carbonyl carbon is from aluminium hydride. Right. So, ఈ అల్యూమినియం హైడ్రైడ్లో ఉన్న హైడ్రోజన్ కార్బొనైల్ కార్బన్తో న్యూక్లియోఫిలిక్ సంకలనం చెందుతుంది. మరి ఆక్సిజన్ పై ఉండే హైడ్రోజన్ ఎక్కడి నుంచి వస్తుంది? ఈ ఆల్కహాల్లో అంటే కార్బొనైల్ కాంపౌండ్లోని ఆక్సిజన్తో బంధం ఏర్పరచుకునే హైడ్రోజన్ నీటి నుంచి వస్తుంది. రైట్. ఇక్కడ మన క్వశ్చన్లో ఏమి ఇచ్చాడమ్మా చూడండి. See here, in the place of hydrogen, deuterium is taken. Right? Sorry. In the place of hydrogen, deuterium is taken. So, deuterium bonds to this carbonyl carbon. Now, the hydrogen bonding to the carbonyl oxygen to convert it into alcohol is from water. So, here there should be hydrogen. So, this compound is correct answer. RCDHOH. RCDHOH. Option C is correct answer. Clear? Right. Now, the same RC double bond O H. First, it is lithium aluminium hydride. Now, second one is D2O. Again, same options are given. Same options are given. What is the correct answer? Use chat box and text the answer. Right. Correct. KGBV Venkatapur, Nagar Kalnoor. Pentavalley students. Right. Option A. Correct. Option A. Because hydrogen coming from aluminium, it bonds with carbonyl carbon, and from water there is deuterium, heavy water. So the deuterium bonds with the oxygen. So RCHODH, RCHODH, it is in option A. So here option A is correct answer. Here option C is correct answer. Right? Now, sorry, 1 minute, Amma. Right. Now, right. See, for example, let us take in the given aldehyde or ketone. In the given aldehyde or ketone, along with carbonyl group, if there is CN, cyanide group, right? And if there is CONH2 group, that is amide group, along with aldehyde and ketone, right? CONH2. Along with aldehyde and ketone, if there is NO2, nitro group, then see if we use lithium aluminum hydride, lithium aluminum hydride, right? Let us take the same groups with sodium borohydride, Cn, CONH2, NO2. Now it is treated with NaBH4, here NaBH4, NaBH4, here lithium aluminum hydride, here also lithium aluminum hydride. Now see, in presence of lithium aluminum hydride, cyanide group will be reduced to CH2NH2. CH2NH2. In presence of sodium borohydride, cyanide group, it does not undergo reduction with sodium borohydride. Whereas CONH2 group, it undergoes reduction with lithium aluminum hydride to form CH2NH2. CH2NH2, right? Now, whereas NO2 also undergoes reduction to NH2. Now here CONH2 group does not undergo reduction with sodium borohydride. Similarly, NO2 does not undergo reduction with NaBH4. So lithium aluminum hydride, it reduces cyanide, amide and nitro group into corresponding amines. Cyanide into CH2NH2, amide into CH2NH2, NO2 into NH2, right? So if we want to reduce only aldehyde group present in the given compound, only aldehyde or ketone, only aldehyde or ketone, whether we have to use lithium aluminum hydride or sodium borohydride. Sodium borohydride. If you want to reduce only carbonyl group, then we have to use sodium borohydride, because lithium aluminum hydride, it reduces CN group, CONH2 amide and NO2 into corresponding amines, right? So lithium aluminum hydride cannot be used. Lithium aluminum hydride cannot be used if aldehydes or ketones consists CnCONH2NO2 because lithium aluminum hydride reduces these groups into corresponding products. Whereas sodium borohydride, it can be used because it does not affect these groups, right? So remember, lithium aluminum hydride cannot be used if given aldehyde or ketone consists cyanide CONH2 NO2 because it reduces these groups also. Whereas sodium borohydride, it does not affect these groups. So it can be used to reduce only carbonyl compounds, right? Now, for example, see nitrogen. Sorry. See, this is the aldehyde, and here product is NH2. Right, this is the product. And in another case, N double bond C. Here, this is the product given. Okay. Now, what is the reagent used in the first case and what is the reagent used in the second case? In the first case, cyanide group is reduced along with the aldehyde. Cyanide group is also reduced along with aldehyde. In the second case, cyanide not reduced along with aldehyde. So, to reduce the cyanide, we have to use lithium aluminum hydride, right? Cyanide is not reduced in the second case. So, which reagent we have to use? Sodium borohydride. So, like this, we have to choose or select suitable reagent. Clear? Right. Now, see, for example, let us take CHO, right? Now, this is one compound, and another compound is, and this is another compound. What is the difference between these two compounds? Here, in the second compound, pi bond is in conjugation with the carbonyl group, right? Double bond and C double bond O. C double bond C and C double bond O are in conjugation, right? Whereas in the first compound, C double bond C and C double bond O, C double bond O, they are not in conjugation. This is the difference, right? So here, when C double bond C and C double bond O are not in conjugation, when they are not in conjugation, this system is called isolated. Isolated, right? isolated positions. Now here, sorry, C double bond C and C double bond O are in conjugation. Now question is, if they are not in conjugation, what will happen? If they are in conjugation, what will happen? That let us discuss now, right? Suppose when C double bond C and C double bond O groups are at isolated position, if we use lithium aluminum hydride or sodium borohydride, double bond C is unaffected. Double bond is unaffected by both lithium aluminum hydride as well as sodium borohydride. Double bond is unaffected when when C double bond C and C double bond O are at isolated positions, right? So C double bond C is unaffected. Unaffected, right? So what could be the product in the first case? In the first case, only aldehyde undergoes reduction. Aldehyde undergoes reduction into CH2OH. This is the product. Now, in case of second case, that is when C double bond C and C double bond O are in conjugation, right? Are in conjugation. That too, this system should be aliphatic, right? This is aliphatic. In aliphatic compounds, right? Then what will happen? If we use lithium aluminum hydride or sodium borohydride, right? Then both the products are possible. What are those both products? One is carbonyl reduction product and another one is double reduction. I mean, double bond and carbonyl both undergo reduction, right? So both reductions are possible. That is double bond reduction and double reduction. Double reduction means C double bond C and C double bond OH. Both groups undergo reduction, right? Both are possible. Then which one is dominating? That is carbonyl group reduction product is major product, right? So here I'll write two products. First, I'll write carbonyl reduction product. CHO group, it undergoes reduction into CH2OH. This is carbonyl reduction, only carbonyl reduction. Now, second product is double reduction. That is double bond C and aldehyde group both undergo reduction. So, which one is dominant? Former one. That is carbonyl group reduction is major product, right? And double reduction product is minor product. Double reduction product is minor products. So remember, when C double bond C and C double bond O of carbonyl are in conjugation, then carbonyl group undergoes reduction. It results one product, and both double reduction C double bond C and C double bond O both undergo reduction to form another product. Carbonyl reduction product is major product, right? When they are in conjugation. Now here, when they are at isolated positions, what is the product? Only carbonyl group undergoes reduction. Double bond C is unaffected, right? Clear? Now, see, we have seen the mechanism how carbonyl group is undergoing reduction. But how it is possible to produce double reduction product? How it is possible to produce double reduction product? Right? Now, let us see that. Sorry. Now, let us see mechanism for formation of double reduction product. So, let us take conjugated aldehyde. C double bond C and aldehyde group both are in conjugation. Let us take the reagent BH4 minus, right? Now, this negative charge, this hydrogen with its electron density, it undergoes nucleophilic addition to this double bond, right? Then this electron density delocalizes here. Now this electron density delocalizes to oxygen. So the product is, see, hydrogen is added to the double bonded carbon. Now C double bond C pi bond delocalizes to next adjacent carbons, right? Now hydrogen is as it is. Here oxygen gets negative charge, O minus. Now see, when sodium borohydride is used, water is added to the reaction medium. At this stage, water interacts with the O minus, right? So now this electron density goes with OH minus, OH. Now it gives H here, OH. Now here double bond. Now this is enol, enol. See, enol, it undergoes tautomerization. Enol, it undergoes tautomerization. So due to tautomerization, what will get? Again, it gives aldehyde. Again, this aldehyde, it reacts with sodium borohydride or lithium aluminum hydride to form corresponding alcohol, right? OH. This is mechanism for double reduction product formation. All of are clear? So in the double reduction, first lithium aluminum hydride or sodium borohydride H minus, it attacks over the C double bond C carbon, terminal carbon. Then pi bond delocalizes. Then carbon oxygen pi bond delocalizes to oxygen. Then in the next step, O minus interacts with the water. Protonation takes place. Protonation of O minus that results enol. Enol. This enol undergoes tautomerization to form aldehyde all, all form, right? This is tautomerization, keto-enol tautomerization or aldehyde enol tautomerization. Again, it undergoes reduction with the lithium aluminum hydride or sodium borohydride to form corresponding alcohol. This is double reduction product. Clear? So remember, When C double bond C, C double bond O are isolated, double bond is unaffected. Only carbonyl group undergoes reduction with lithium aluminum hydride or sodium borohydride. When C double bond C and C double bond O of carbonyl group are in conjugation, both carbonyl reduction product and double reduction products are obtained with the former dominating. That is carbonyl reduction group dominates. That is major product. And we have seen the mechanism, right? Similarly, before this, what we have discussed before this, we have discussed that if we use lithium aluminum hydride, it reduces CN group, CONH2 group, and NO2 group. Whereas sodium borohydride, it does not affect CN group, CONH2 group, and NO2. Remember this. Now, see, for example, sorry, lithium aluminum hydride is used. Then what is the product? What is the product for the first one? కేజీబీవి జిన్నారం ఏదో ఈమోజీ పెట్టారమ్మా, దాని మీనింగ్ ఏంటో నాకు తెలియదు, టెక్స్ట్ చేయండి ఒకవేళ ఇది మన క్లాస్కి సంబంధించింది అయితే. రైట్ నవ్ ఇక్కడ ప్రోడక్ట్ ఏమొస్తుందమ్మా? ఓన్లీ ఆల్డిహైడ్ గ్రూప్ ఉంది, రైట్? సో ఆల్డిహైడ్ గ్రూప్ ఇట్ అండర్గోస్ రిడక్షన్ టు ఫార్మ్ ఆల్కహాల్. నవ్ ఇప్పుడు ఇంకొక ఎగ్జాంపుల్ తీసుకుందాం. రైట్, ఈ కాంపౌండ్ దీన్ని ఫర్ ఎగ్జాంపుల్ లెట్ us టేక్ సోడియం బోరోహైడ్రైడ్. Sodium borohydride with ethanol. Instead of water, let us take ethanol, and along with this, if we take InCl3, then what could be the product? What could be the product? డిఫరెన్స్ ఏముంది ఇక్కడ? రియేజెంట్. ఇంతకుముందు మనము లిథియం అల్యూమినియం హైడ్రైడ్ లేదా సోడియం బోరోహైడ్రైడ్ను వాటర్ లేదా ఇథనాల్తో తీసుకున్నాం. ఈ InCl3 అనే సాల్ట్ లేదు, రైట్? InCl3 సాల్ట్ లేనప్పుడు ఏమని చెప్పుకున్నాం మనము? ఈ సి డబుల్ బాండ్ సి మరియు సి డబుల్ బాండ్ ఓ రెండు ఒకదానికి ఒకటి సంయుగ్మంలో ఉన్నప్పుడు, కాంజుగేషన్లో ఉన్నప్పుడు ఏమవుతుందమ్మా? కార్బనైల్ రిడక్షన్ ప్రోడక్ట్ వస్తుంది. డబుల్ రిడక్షన్ ప్రోడక్ట్ అంటే సి డబుల్ బాండ్ సి రెడ్యూస్ అవుతుంది, సి డబుల్ బాండ్ ఓ రెడ్యూస్ అవుతుంది. కార్బనైల్ రిడక్షన్ ప్రోడక్ట్ ఈజ్ మేజర్ ప్రోడక్ట్ అని చెప్పుకున్నాము. ఇప్పుడు InCl3 సాల్ట్ ఉంది ఇక్కడ. InCl3 సాల్ట్ ఉండడం వలన సి డబుల్ బాండ్ సి అనేది అన్ఎఫెక్టెడ్. సి డబుల్ బాండ్ సి అనేది అన్ఎఫెక్టెడ్, రైట్? సో ఉత్పన్నం ఏమవుతుంది? సి డబుల్ బాండ్ సి రెడ్యూస్ అవ్వదు. సి డబుల్ బాండ్ సి అదే విధంగా ఉంటుంది. కేవలము కార్బనైల్ గ్రూపు మాత్రమే ఆల్కహాల్గా రెడ్యూస్ అవుతుంది, రైట్? ఇది 100% ప్రోడక్ట్ అంటే రెండు ఉత్పన్నాలు ఏర్పడవు, రైట్? రెండు ఉత్పన్నాలు ఏర్పడవు. సో సి డబుల్ బాండ్ సి అండ్ సి డబుల్ బాండ్ ఓ కార్బనైల్ గ్రూప్ రెండు కాంజుగేషన్లో ఉన్నప్పుడు, వెన్ దే ఆర్ ఇన్ కాంజుగేషన్, if it is reduced with NaBH4 or LiAlH4 in presence of any lanthanide salt, ఇండియం అనేది లాంథనైడ్ అమ్మా, వీ కెన్ యూజ్ CCl3 ఆర్ ఎనీ లాంథనైడ్ సాల్ట్, సీరియం కానీ ఇండియం కానీ ఏదైనా లాంథనైడ్ సాల్ట్ను ఉపయోగించినప్పుడు కేవలము కార్బనైల్ గ్రూప్ మాత్రమే రెడ్యూస్ అవుతుంది, సి డబుల్ బాండ్ సి రెడ్యూస్ అవ్వదు, రైట్? ఓన్లీ carbonyl group undergoes reduction. So remember, when NaBH4 as well as LiAlH4 is used to reduce only carbonyl group, right? When it is possible, if LiAlH4 or NaBH4 is mixed with any lanthanide salt like InCl3 or CeCl3, any lanthanide salt, then only carbonyl group undergoes reduction. Only carbonyl group is reduced, but not C double bond C, though it is in conjugation with the carbonyl group, right? Now, for example, ఇక్కడ ఒక కీటోన్ తీసుకుంటాను, ఇది కీటోన్, రైట్? ఈ సి డబుల్ బాండ్ సి సి డబుల్ బాండ్ ఓ రెండు కాంజుగేషన్లు ఉన్నాయి. బట్ ఇచ్చిన ప్రోడక్ట్ ఏమి ఇచ్చాడంటే ఓన్లీ సి డబుల్ బాండ్ ఓ మాత్రమే రెడ్యూస్ అయింది, సి డబుల్ బాండ్ సి ఎఫెక్ట్ అవ్వలేదు. అప్పుడు ఆప్షన్స్ ఇచ్చేసి క్రింది వానిలో ఏది సరైన కారకము, విచ్ వన్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ సూటబుల్ రియేజెంట్ అని ఆప్షన్ ఏ, ఆప్షన్ బి, ఆప్షన్ సి, ఆప్షన్ డి అలా ఇస్తాడు, రైట్? ఇక్కడ ఏం తీసుకోవచ్చు మనము? లిథియం అల్యూమినియం హైడ్రైడ్ అయినా వాడచ్చు, లేదా సోడియం బోరోహైడ్రైడ్ అయినా వాడచ్చు. Along with this, what should be there? There should be lanthanide salt like CeCl3. Then it is correct, right? Clear? సో మీరు వీటిని ఏం చేస్తారంటే కీ నోట్స్ తయారు చేయండి అమ్మా. కీ నోట్స్ తయారు చేసి రిపిటేటివ్గా చదవాలి. రిపిటేటివ్గా చదివినప్పుడు మాత్రమే మీకు గుర్తుంటుంది. ఓకే, ఎక్స్ప్లెనేషన్ పార్ట్ క్లియర్గా ఇస్తున్నాను. మీకు ఏదైనా డౌట్ ఉంటే టెక్స్ట్ చేయండి, లేదా ఈ వీడియోను వినండి, లేదా దీని పీడిఎఫ్ పెడుతున్నాను గ్రూప్లో, ఆ పీడిఎఫ్ను చూసైనా నోట్స్ ప్రిపేర్ చేసుకోండి, రైట్? ఇవన్నీ చేసిన తర్వాత కూడా ఇంకేమైనా డౌట్ ఉంటే వాట్సాప్లో టెక్స్ట్ చేయండి నాన్న. క్లియర్? సో ఐ వాంట్ టు స్టాప్ హియర్ ఫర్ టుడే. సో మండే వరకు మాత్రం మీరు అల్కైల్ హ్యాలైడ్లు, ఎరైల్ హ్యాలైడ్లు అన్ని కాన్సెప్ట్స్ చదవండి. చదవడంతో పాటు రేపు సండే ఆఫ్ కాబట్టి కొంత టైం స్పెండ్ చేసి షార్ట్ నోట్స్, కీ నోట్స్ రెండు ప్రిపేర్ చేయండి. ఓకే, థ్యాంక్ యూ వన్ అండ్ ఆల్.